In this video, we will be understanding how chi-square test is used and in what situation the chi-square test is used for the purpose of data analysis and decision making. The chi-square test is used in several situations for the data analysis, such as categorical data analysis that contains nominal or ordinal variable rather than the continuous numerical data such as age, temperature, etc., and for testing the independence between the given variable so as to find out if there is a significant relationship between two categorical variables. Let us discuss and understand how categorical data is analyzed using the chi-square test. Suppose a situation is given like here, a restaurant chain wants to know if the family members or type of family members of customers influences the food preferences or not. And hence, the research question will be, is there a significant association between family members and type of food preferences among the customers? Here, the table value which have been given, it is called as the observed frequency because these are those values or that data which has been collected by the researcher at the time of data collection from the respective respondents. Let us begin with development of the research title for the given situation. Since we want to see the association or relationship between the family members and type of food preferences, that is, both are the categorical variables, and hence the title would be a study on association of family members with the type of food preferences, or the title can be also study on relationship between family member and type of food preferences. So we will be rewriting the observed frequency again, but here we have to add one more column and one more row for making the total of given observed frequency. So for the first row, the total of row is 70. For the second row, the total is 65. For the third row, the total is 45. And similarly, the first column total is 75, second column total is 55, and third column that belongs to healthy type of food, the total becomes 50. And then finally, we have to write down the main total, which will be either the total of rows total or which will be total of columns total. That comes to 180. For your easy understanding, you can even mention the numbers as given here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, so as to avoid any kind of a confusion when we will be rewriting the expected frequency, which we will be calculating in our upcoming step. So as we discussed in our earlier video, let's develop the null and alternate hypothesis statement. The null hypothesis statement is the negative assumption that should show there is no association, and hence we will have our null hypothesis as follows. There is no significant relationship or there is no significant association between family members and type of food preferences. And then we will be formulating the positive alternate hypothetical statement mentioning there is a significant association or relationship between the family members and type of food preferences. In case of chi-square test, the decision rule says that if the chi-square value, that is the calculated chi-square value, is larger than the table value or critical value, then we should reject the null hypothesis. So now let us calculate the expected frequency for each of the given observed frequency. And the formula for calculation of expected frequency is rows total multiplied by columns total divided by mean total. So let us calculate the expected frequency for the first observation, which is associated with young age and fast food. So our formula will be E stands for expected frequency, and write young and fast food, and then find the first rows total, that is total of young age, which is 70, and the first columns total, that is the total of fast food, which is 75, and divide it by the grand total, which is 180. So the calculation gives us the expected frequency for the first observation as 29.166. We will keep minimum 2 to 3 decimal points for further calculations. Similarly, we will be doing calculation for all the given observed frequencies one by one as shown on the slides. This is our final table, and in the final table we will be having all the columns which is been given in the situation, as well as the calculation that we have done to find out the different values. So the first column contains the type of family members, the second column contains the type of food preferences, third column will be the observed frequency values which are given into our situation, then the calculated expected frequency values in the fourth column. Then we have to subtract the expected frequency from the observed frequency. The value obtained after the subtraction, that is O minus E, we have to make square of it, and then in the last column we will be writing O minus E square divided by E, that is the expected frequency value. Once we obtain O minus E square divided by E for each of the row, each of the value we have to add so as to find the final total, that is the summation value. And here in this situation, the final summation value of O minus E square divided by E is 14.742. So this final total value obtained here is 14.742, which is our calculated chi-square value. Now we have to calculate the degree of freedom. This calculated chi-square value we have to compare with the standard critical chi-squared value at degree of freedom 4 and at 0.05 significance level. Normally this critical stable value is given in the examination, so you need not to search for it. Since there are 3 rows and 3 columns given in the data set, that is 3 by 3 data set is given. So the formula for calculation of degree of freedom is rows total minus 1 multiplied by columns total minus 1. So putting the values here, there are 3 rows and 3 columns. So 3 minus 1 multiplied by 3 minus 1, that comes to 2 multiplied by 2 is equal to 4. So 4 is our degree of freedom, and normally the significance value we take is 0.05. Now we have calculated x square value, which is 14.742, and the table value at degree of freedom 4 and at 0.05 significance level, which is 9.49. The decision rule says if the calculated chi-square value is larger than the table value, we should reject the null hypothesis. Our calculated x square value is 14.742 and the table value is 9.49. So obviously the calculated value is larger than the table value at degree of freedom 4 and significance level 0.05. We should be rejecting our null hypothesis. Now, since we are rejecting our null hypothesis, we will be accepting our alternate hypothesis that says there is a significant relationship between type of family members and food preferences. So let's make the informed decision by saying there is a significant association between the family members and type of food preferences. Young people choose fast food much more than the expected. Older customers choose traditional food more than the expected, and middle-aged customers are closer to expected counts across the categories. So the informed decision will be the restaurant owner should target different food categories to different age group of family members so as to attract all age group of customers and ensure business and profitability. As we discussed earlier also, this informed decision writing is more important. That is what the main role of an MBA student will be in the different business situation to take the correct informed decision and helping organizations to perform and earn maximum profitability. So simply you should remember that whenever you will be writing the informed decision, you have to just explain whatever is mentioned into your alternative hypothesis statement, because this is what we have accepted, this is what we have proved, and based on that, we should be able to take the correct informed decision.